So yeah, the topic is basically distributed workload generator for performance and load testing using emerging technologies. The emerging technology, we can call it out as an open source technologies also. Okay, that's the topic, and we'll talk about more details in the next couple of slides. I think abstract you may be read in the conference itself. I no need to repeat again. Let me go through the agenda, what we are going to cover in this particular presentation. So basically, as I mentioned in the intro, I'm from the server validation group. We validate the servers end to end before we release to the market. Actually, it's like any software. We actually do the hardware testing. Basically, servers we validate it, and we have a specific phase called offer test. And what exactly we do in the offer test, and what are the current tools we use in the offer test. What are the challenges we face with the current tools what we have in the offer test actually, and what is the solution we built and technology stack and overview of this particular solution and what we are going to what we are working on the next. And also we have I'm covering a small demo in the end of the presentation, which you guys can able to get to know more details on this. Getting some chart. Okay. Yeah, feel free to stop me or ask any questions, or you can drop the questions in the comment in the chat box, and we can able to take it up next. So server validation group, actually, we located in 3 different regions. One is in Austin, Bangalore, and Taipei. I am from Bangalore Development Center. As I mentioned in the previous slide, we actually do the end-to-end server validation before we release to the market. It contains unit testing, functional testing, regression testing, and offer testing, or we can call it system testing. And finally, we do the area validation test, and we release the system to the market. It's like any software, we actually do the a piece of hardware testing actually, okay, with all the software stack, operating system, and all the stuff actually. Okay, so that's what majorly we do as part of our validation group, and we look at it in these 3 locations. So in this particular what you call the presentation, we focus more on offer test, which is basically before it's like an end of the test phase. I think you maybe heard about non-functional testing. In our world, we call it system testing and offer testing actually. What exactly this testing means, we actually look at a server and we see that how this server will be used in the customer side actually. We do a customer focused validation effort on the server to make sure that the server actually works as per the what we defined as per the definition. It works in the lab actually. So we try to simulate the real world customer use cases like in typical system applications on the server, and we try to test the system, and we try to put the load, we try to put all the different situations, and we try to see that how the system is behaving actually. Okay, that's what we call it an offer testing more. It's more like a customer focused testing actually. So if you look at it, any typical customer, when he take the system and he puts into the data center or any lab, he try to deploy the configuration, and he try to run his workloads on the system, and he monitoring it on the system. And also if there is any security patches or firmware updates, any software updates, he do that one. And then end of the system lifecycle, they will retire the server actually. Similar like that, we also try to deploy, we try to simulate the workloads on the system, we monitor, we update the things, and once it's done, we retire it. Mostly the life cycle of this testing is more like in a 5 to 7 days of this testing cycle for a particular configuration. So in this presentation, what we talk is that how do we simulate the customer workloads, what tools we use, what are the challenges, and all things we talk about. So as I mentioned, we actually use some simulators or load generation tools. You may be heard about pretty known tools like an Ixia, Neoload, Load Runner. These are a lot of tools we use over the years, from the last couple of years actually. One of the key challenges what we have with these tools is that we have 3 different labs. Every lab should have their own local instances, because we cannot run across geo sites because a lot of network traffic will create a bottleneck. So every lab we need to install it in the local labs, and then we need to maintain the hardware, we need to maintain the licenses, and the hardware is pretty expensive also, the infrastructure what we build for this particular load test. So what we end up is that it's become more complex, expensive, and a lot of licensing challenges and all those things to manage it. And also we need to have a highly specialized performance engineers to develop any new scripts, to do any new offer testing scenarios or test situations actually. This is also one of the challenge. And last one is the data analytics and correlation, because we generate a lot of data which is inside the proprietary tools. For if you wanted to get to know any more analytics, or if more any data analysis, it's become very difficult because we cannot able to get the data very easily from the tools what we have in the market. Mostly I'm talking about the proprietary tools which are available in the market. These are typical challenges. I think any tool, when you look at it, these are the typical challenges we face in the market, whatever we have. So what we came up is that we thought we wanted to build our own solution, which is basically like, and we wanted to build an on-premises cloud type of solution, which should able to meet our requirements, the scalability across labs, all the stuff actually. Okay, so we built a solution which built is based on the JMeter, one of the key technology, and Docker, Elastic Stack, and we also use some of the Axon UI, which is basically ingrown, what do you call it, a tool. Okay, and the best part is that if you look at it, any load generation solutions, we need to use the proprietary hardware to run as a load generators. But we are from the Dell side, we have a lot of servers. We use our own hardware as a load generators with the solution. And a couple of other advantages, you can see that it can scale across. Yeah, we can scale across regions and across labs because we have a connected labs are connected to the across the sites actually. With that solution, we can able to connect different sites with the network, and we can able to run the load and different load generators across labs. And again, it's again JMeter, so we can able to build or incorporate new workloads based on the technology and all the stuff. It's JMeter supports. We talk about in the next slide. And again, it has a REST API so that we can able to automate and we can able to integrate new workloads and new execution cycles. End of the day, all this data what we are running with the JMeter logs, transactions, workloads, and all the stuff, it's again stored in our own database so that if we want to do any advanced analytics or dashboards, we are able to develop and we can able to visualize the data. Okay, so that's pretty much on the high level solution, but we will talk about more key technologies in the next slides. These technologies you may be heard in the market, pretty widely known open source solutions actually. And the first one is JMeter. JMeter supports many types of load tests, and you can able to write your own load scripts also using the JSR 232, what you call a sampler. We mostly use JSR 232 because we have a lot of customization, a lot of what you call as scripting we do to generate a efficient load actually. Okay, and load generators, JMeter is basically an open source tool, and it's a platform independent. It supports multi-threads and multi-thread framework actually. There are a lot of information available in the market, and JMeter we chosen because it's a very popular tool in the market, and again it's open source. Okay, and the next two technologies are pretty much known ones where you may know that Docker and Docker Swarm. Basically, Docker is like an portable, resource efficient solution where we can able to run the container with a specific scripts, and it can run quickly. And once it's done, we can dispose it more fastly actually. And the cluster management, because we have across sites, we have Docker nodes, so we use the Docker Swarm, which is basically a native Docker cluster orchestration solution. And it has a load balancing, it has a REST API so that we can create the jobs, we can monitor the jobs, we can delete the jobs using REST API itself. It's an entire ecosystem is again open source itself. And finally, we have an Elasticsearch, basically a database where we store every transaction what we generated in this entire solution into the database, either for searching or timeline data, timeline charts, or all these things. We use that one. And again, it's a complete open source, and it has a REST API so that we can even send the data, we can read the data, we can visualize the data using the Grafana. So these are the top key technologies which we are talking, which is completely open source technologies. Apart from that, we have other technology stack you can see here, which is more tools which we use as part of the solution. Again, and as part of the physical layer, we use Dell servers because we would like to get more power from the systems to generate the load. So we use Dell servers and high-end network cards as part of the load generators. Again, we use Ubuntu to deploy in all the systems so that we don't want to go to any virtualizer in any Windows operating system because again comes with the licenses and all the stuff. And then we deployed the Docker and we created Docker cluster across the nodes. And finally, we have Harbor. It's basically, if you heard about the Docker Hub, it is similar to like that, a Harbor, internal Docker registry, which is again a open source solution from the VMware, where we keep our Docker images there so that we can able to download as many times we image from the local repository. So that's pretty much from the infrastructure side. But coming to the programming languages, what we use, the appliances and databases, you can see here, most of the things we developed in Python. And the Groovy we use in the JMeter scripts actually, and JSR 232 is pretty much similar to Java. So as part of JMeter, we use that programming language to develop the JMeter scripts, and then we use Elasticsearch for entire database. We have a lot of interfaces for the users. Most of the tools, it's all open source, apart from the Axon, which is an ingrown like a web interface for running the jobs and other extra things. And then we have a port runner is for the monitoring the Docker cluster, Zabbix for the monitoring infrastructure, Grafana is for the visualizing the data what we have. I have a demo where you can see all these things, technologies what we used and how we are able to build the solution. Again, we have the Bitbucket for source code and Confluence and Jira, and we have a DevOps pipeline to build the images, push the images to the production, and run the jobs seamlessly to the end user actually. This is a high-level technology stack, but how this technology stack works and connects to our project, we will talk in the next slides. So this is pretty much like a pretty high-level overview of the solution, what exactly happens. Okay, so I had an animation, but I couldn't able to play here. But I'm just explaining you guys. When an end user goes to Axon as a web interface, he goes to that web interface and say that I would like to run this particular workload, this many number of virtual users. For example, I want to run 1,000 users, 10 users with particular web application. I want to hit the load actually. So what basically Axon will do is that it will actually submit the job to the Docker cluster, and it will also pump the data to the database. So the Docker cluster across nodes take this particular requirement and run as many as containers, as many as users. For example, if you ask 10 users, 10 containers will come up. So each container will have a JMeter script basically, which loads and starts running the stress actually, so that over the network, your application under system under test or application under test will be get stressed actually. As part of the data collection, we collect all the data, what is generated in the load generators, like a JMeter transactions, JMeter errors, everything we generated. What we generated, we sending to the Elasticsearch as a live, as well as the system utilization also, we send it to the live to the Elasticsearch. Using the Grafana, we actually visualize both data sets, like how much load generators are generating and what was the server is getting utilized or what was the server's utilization, CPU memory utilization. So this way we know that is there any issues in the load generator, is there any errors, is there any transactions failure, how the transaction speed for each transaction in JMeter, we'll be able to get the data, as well as how the server is running, like a CPU, memory, network, all that resource utilization we'll be able to get and correlate in the Grafana. So this is pretty high level. I mean that we will talk about more details in the next slides. But the main the concept is that there is a lot of Docker nodes which brings the containers. The containers are like virtual machines or some load generators, which basically run the JMeter script over the network to test your system under test. The system under test could be your web server, or database server, mail server, any type of application it can able to test it. Again, this slide is a little bit looks more complex, but I had an animation, but I couldn't able to present here. But yeah, so what exactly happens is that a little bit more, what is the insights about the data flow, so that you can understand how the way this entire transactions, how the way the data flow happens, you can able to see from this slide. So when a user goes and submits to the front end, basically the front end actually what it do is that it will submit the request as a Docker service. It's called as in the Docker, it's called Docker service into the Docker cluster, and also the Axon also pumps this information into the database. Like what is the Docker service details, what is the workflow details, what is the JMeter load details actually. Okay, basically the JMeter load details means it's a JMX file in the JMeter world. So we actually pump this directly script into the database, so that when the container comes up using the Docker service, the containers comes up across the load generators. These JMeter Docker containers go to the database and reads the JMX file and starts the JMX load using the JMX file, so that you know that the JMeter Docker containers are testing your system under test actually. So this is the continuous process where the JMeter Docker containers starts JMeter script and stressing your system under test. At the same time, as we told that containers will be sending all the container logs, metrics, JMeter logs to the database, so that we can able to view the data in a live in a Grafana action. So this is the way we can able to bring the containers and stress the system using the particular workload, whatever we choose. Now, one of the best features for this solution is that users can able to scale up number of users dynamically. Compared to other tools, you may maybe observe where we need to stop and again increase more number of users. But here you can able to do the seamlessly using the Docker service. So user goes back and says that now I'm running 2 users. Can you increase or scale up to 3 users? So once you submit the job, the Docker service will be updated with 3 users. Again, the new container will come up. It will do the same process of getting the data from the database and running the workload and sending the data back to the containers. So this is the continuous process where users can able to scale up and scale down. And also we have a feature called profile workloads, where daytime you will have a high amount of utilization, and nighttime you will have slow utilization. And we can actually define the profile, like how many hours you want to have a high, how many hours you want to have medium, how many hours you want to have a low, so that we can able to customize and the load will be generated as per our design actually. And at the same time, as I mentioned, the server under test, the system under test, the application under test will send all the logs, the software logs, OS metrics, and other logs to the database, so so that we can able to correlate this data in one interface. Okay, so this is pretty much high level, and you can see here the Docker TS means Docker service, JMeter Docker container, or system under test basically the name. Okay, so this is a pretty high level solution what I talked about, and most of the tools what we use is completely open source. And now we will be talking in the next slide like in a one of the challenge what we face like in a site to site, how do we able to run or how do we able to manage one single solution across different geo sites actually. So for example, I mentioned we have two different sites. So one is Bangalore Development Center, one is Austin Development Center. So when a user goes to the Axon, he submits a job with different a specific location. Like in Bangalore Development Center, we want to run this particular workload. So basically, what we did is that the entire Docker cluster we geo tagged certain nodes. Basically, Bangalore Development Center nodes tagged as Bangalore ADC, and Austin Development Center nodes tagged with an ADC. So when a user submits a job, he will choose which lab he would like to run this particular workload. So when he submits a particular job with a particular location, the Docker Swarm, basically the Docker Swarm will take care about the bringing the containers of particular service in the particular location which we chosen. So for example, when we select BDC, the containers will come in Bangalore lab, BDC lab, and if they choose an ADC, it will come ADC lab. So what we are trying to do is that we consolidated the solution, but still we provide an option where users can able to scale their load generators in their own lab. One of the key things because of this geo-located workload generators closer to the system under test, because we will give having a high amount of network traffic which is actually inside the lab. So we don't want to run the what do you call it, traffic between the different labs to the system under different labs. Actually, it actually create a bottleneck in the network. So we actually try to make sure that the systems under test will be geolocated in the same lab where you have the load generators, so that you will get a highly good traffic and efficiently your system will be stressed actually. So this is a way we actually what we faced the challenge in the previous tools we avoided, and we are able to overcome that, and we are able to scale up to different regions and different sites with the load generators and having a single consolidated solution. With that, we are able to run seamlessly the load workloads on their own labs. Okay, so now we talked about solution, but what type of workloads we supported at this point on? Right now, we have pretty what you call in standard or industry-wide workloads we have. For example, we have web workloads. If you have web server, it keeps on using our JMeter script. It keep on hitting the web server with different combinations and different operations, so that your web server will be stressed. Actually, you may be having web server in IIS or Apache. We're still able to generate the workload on the same system. And then we have a high, good amount of network workloads. Actually, basically, if you have a FTP or a SMB server running on your system, we'll be using that file server protocol to stress your system. Which is this particular workload efficiently we use for the network cards or disk drives to stress, because this particular workload will be generating high amount of network traffic and also a disk utilization. And we have a couple of more workloads we have as part of the solution. One of the thing is basically, very standard and industry-wide workload, basically the mail workload. You may have a Microsoft Exchange or SendMail in your system, and we try to run virtual users to send mails, read mails, and delete mail operations, and every high size of attachments, so that your Exchange server will be stressed, and indirectly your system or test will be stressed actually. So this is one of the very widely used workload. And then we coming to the database, we have touched almost all the database workloads. If you look at it, MS SQL, MySQL, Oracle, MongoDB, almost all industry-wide databases, we actually have the workloads. These workloads create different type of queries, insertion, delete, all the create, delete, update, and all the operations it will do, search and all these things, which eventually stress your system actually. Apart from that, we also have a new workload called OmniSky, which is another database which basically runs on GPU cards, which is high performing cards actually. So these cards we use this OmniSky database to stress it actually. So this is a newly introduced workload which we have in the lab actually. Okay. So I think up to now, whatever I explained, basically we have faced some challenges, the cost and the licenses and the load generators maintaining and all the stuff. So we thought, why can't we build a software with open source solutions, and we use our own Dell hardware with high network cards, high storage, and all the stuff, so that we can able to pump our own traffic to our own systems, so that we can get efficiently. And we build this solution with the different workloads, completely open source tools, and we are using this as part of our projects. Before I go, I'll jump to the demo. so that you will get some fair idea about that, what exactly it works, how it works, and some of the key technology tools in this particular you can see in the particular picture. So yeah, just a slide demo where we have a web server which is running a random number so that you can able to generate high CPU stress on your system. So the web server basically running a PHP script which is generate a random number so that it will eventually stress the system. So this is one of the example I'm trying to demonstrate here so that you can see that how the stress is going to happen on the system and all this stuff. So you can see that the web application, basically it's a PHP application which runs thousands of random numbers, generates the traffic on web will be less, but the CPU stress will be very high with this particular workload. So what we did is that we created a web application and it runs on system. Now, this is a web interface where users will providing different information like what is the web server, how many users you would like to run, which lab you would like to run. These are the information we take from the user, and we try to create the Docker service with this information, and we store this information into our database. So you can see that all the information we provide once you submit this. This is like a very similar to a small web interface. You can consider that way, but it was built in a tool called Axon. So we use the same framework actually. So now you know that we created service. Automatically, the service will be created in the backend cluster. It's called the one more Docker service will be created with one replica. Basically, we create one user with 8 threads in the JMeter terminology. So once it runs, the JMeter script will be launched with container inside the container, and which is stressing your system with multiple threads hitting with the same web endpoint actually. So you can see that the CPU utilization went to 50% now. So now you can see the utilization is increased, and this is the way we can able to stress the stress system. And we also use the Grafana to monitor this entire utilization, what's happening on the system. And we also have a small dashboard web app where user can able to run what is the workload, what is the dashboard link, and all the stuff. And we also send an email to the user where he can able to access the same dashboard link. So now we can see that the dashboard, it's a pretty much lightweight dashboard here. Number of active containers, number of users, what is the error percentage, how much, what is over the time, what is the transaction speed per. These are all the data coming from JMeter, but we pump the data to the Elasticsearch database and we use Grafana to visualize this data actually. So now we can see the data in the live from the Grafana without going into the container and seeing the JMeter logs. Now we are seeing that, okay, we are running with one user, it's around like 60% is getting utilized, but we wanted to scale the number of users to more so that we can able to get 99% of CPU utilization. So what we do is that we will go to the same web interface and we increase the number of users to 2, or technically we provide tell that we need more number of users so that it can run more number of virtual threads and it will stress your system. So now we submitted a request with 2 users. The things will be taken care. The service will be updated with 2 users. And now once 2 users comes, the second user gets a container. Basically, the user is basically a container. And again, it has its own threads. JMeter scripts will start testing the same system. So here you can see that now 2 containers running parallelly with the JMeter script on the system. So you know that now the CPU utilization went to the 99%. This is the way user can able to scale up and scale down. Again, what we did now provide 2 users manually, but it has a REST API, so the user can able to use REST API to control basically the number of users, so that he can able to dynamically control the users how many you wanted in a daytime or a night time, all this stuff. So this is a way you can able to scale up and scale down, and you can able to run the workload and you can monitor the workload data from the Grafana. And once you're done, you can able to go back and stop the workload using this particular email alert, or we have web interface. Once you stop, basically it remove the Docker service. Once the Docker service is removed, the containers which is run using Docker service also get removed, so that the traffic on the system will be erased, actually stopped. So you can see that now the Docker service is not there anymore. And the same thing will happen in the dashboard. It will not show up, no more active job, and we can see that it will reflect in the system also. The utilization will goes to 0. So this is the continuous process where the process is very similar for the web workload or a database workload or a file workload. The only JMX file will be different, and the workload runs when you user can able to scale up, scale down, and eventually can stop, and you can able to monitor the workload data in the Grafana dashboard. So this is the life cycle of what we have built for this particular entire JAS solution. One of the key things is that JMeter has some technology called JMeter Master, what we call as a server concept, but we didn't use that concept. Why? Because when the containers actually have a failover, when the load generators fails, the containers can come up in the different systems due to the load balancing of the Docker swarm, At that point of time, the master may not able to reach to the servers because the server's IP address may change. Due to that, what we done is that we remove the master server concept, and we use every container is like a server which reads the data from the database and starts the workload. So every container independently runs the workload without knowing that there is another container is running same thing actually. So there is no master server concept here. Everything is server. Every container acts like a server actually. You will get to know more details if you got to know more about JMeter, but that's the concept which we use as part of this. Yes. And what we are doing actually, we are actually now promoting more this project to the external teams, and we also working on next generation workloads. Like, and you may have a video streaming server or a machine learning workload or a social media platform where the JMeter can able to reach out these applications and create different threads, different videos, different streaming, and all the stuff, so that the system will be stressed with this particular workload. These are the next generation workloads we're working on. At this point, we did a couple of POCs, and we are working on the implementing the JMeter scripts for the same thing. And yeah, this is one of the biggest project. For example, what we are running this project for around like in the last 4 years, we are running this project in our labs, and we have run around like in a 190 plus projects with this workload. Actually, this is one of the biggest what you call it, cost saving project for us. That's around like $5 million we're saving with this project over the last 5 years. Because like when we're looking at the XC and all things, it's like $3.3 million we spend. Now we are not spending anything, and we are actually using our Dell servers to stress the load generators. So that's one of the best way to save our cost, and also getting next generation workloads more easily into the system actually. So that's pretty much from my presentation side, and we would like to share more knowledge. And if you guys have if you guys need any more details, how the technology stack, how the interactions happen, you can feel free to drop a mail to us at jazz@dell.com, and my team and me will be able to happy to respond and help you guys actually. So that's pretty much, and let me know if you have any questions on the same.
Cool. That was a wonderful presentation. There was so much detail and quite a lot of information. Let's wait for some questions. Yeah.
Sure.
The audience, please, if you have any questions, Vishnu is available here to answer your questions for the next couple of minutes. Was there any, this is while we wait for some questions, I just want to know, was there any sort of drawbacks that you saw because of the usage of JMeter in this that, we should be mindful of, or we should, should consider while we, take this kind of approach?
Yeah, I mean, there is one challenge we had is that JMeter is very powerful. But when we put this in the container, correct, container will have their own specifications. For example, it cannot run so much of memory. For example, JMeter memory, heap size issues, and all the stuff. We started seeing at one point early stages. So what we did is that we did a performance fine-tuning analysis on the JMeter with container with workload, so that we can able to specify the specific memory and CPUs for the container when the JMeter is launched and running actually. So initially we had that particular issues when we specified one size, and when we're running the heavy workloads, the JMeter is to get the heap errors and all the stuff because it has a restricted space and all the stuff. That's the couple of things, but there are a lot of community available in the JMeter side and Docker side.
Yes.
So we used to find the things and all the stuff. This is around like in 2017 we started this project, around like 4 years. It was one of the we got a lot of awards for this project because it was a highly saving cost actually, not just for server. Now we are promoting, because we have recently EMC was integrated. So we are actually promoting the same solution for the EMC teams, so that they are spending a lot of dollars in the performance and load testing tools. So we're trying to promote more and more now actually, because it's a zero cost investment.
Yeah, sounds good. So when you said about fine tuning, was it on the JMeter heap size, or in configuration side, or was it more on the container
Both
side?
sides actually. One is the JMeter heap, the workloads based on that one. For example, if you're running a file workload, JMeter heap will be more actually, because you're downloading a file remotely, or the FTP protocol, it takes more. So we need to make sure that the heap size as well as the container which we create, correct, we specify the memory and CPUs how much you wanted to use for a container. So we used to fine tune, for example, network workloads, we used to give more memory so that the heap size will not get issues. And for example, that web and database workloads, we don't take too much of data. We just run the trigger a transaction and the database will be searching all the records. So we don't get too much of data from the database to the geometry container. So there we used to have high CPU and less memory. These are the fine tunings we used to do over the time. Actually, it's not like first day we did it, but over the learnings, over the period of time, we understand and we implemented the changes.
Cool. Sounds good. So we have a question from Richard. The load generator server, should we host them in-house or cloud like AWS or Azure? What's your recommendation?
The thing is that we are actually a server organization, so we don't buy servers. We used to use old generation servers repurposed for the solution, so that we are able to save a lot of dollars for that one. But if you are looking for what you call it, you wanted to maintain a server, you want to go for cloud based on the amount of traffic. Actually, for example, you wanted to do more internet traffic, correct? You better to go with cloud so that you can able to get seamless experience what customer or what end user is going to get. Okay, or if you're doing more like if you're doing a terabyte of traffic transfer on a particular system to do some particular protocol testing, I think it would be better to do an in-house server and do the things. And one more thing is that when I mentioned the server, correct, it no need to be a server actually here. It can be a virtual machine or it can be a server, anything. It doesn't know actually because it installs Ubuntu and on top of that we install Docker application. From there, Docker will be virtualize the containers and take care. So we use servers because we get more. We don't want it to virtualize and on top of that we deploy the Dockers. We just take the plain vanilla Ubuntu OS and top of that we install the Docker so that we get very efficiently be able to use the resources for the load as a part of the load generators.
Right, sounds good. So when you mention about the choice of servers, won't that also play a role in us running the load without any sort of issues? Like we just spoke about how there was some challenges about JMeter running without any sort of restrictions in the container. So choosing the server would also probably play a massive role in us having a smooth process with this generation?
I mean that server also correct. It's the CPU cores and the
Right.
memory,
Yeah.
okay, which will be taking care of the container. The major role what we observe is the network card section because the network cards are actually we used to have we have in the lab with 100 gig network cards to get high traffic on the system. Okay, the network card used to play a critical role for us because the CPU memory is more or less over the generations it will behave for us more or less same only because it has Ubuntu and on top of the Docker used to fine tune the things. For us, major challenge we used to face with the network cards because we have different network cards, different speeds. We want to have high traffic network cards in the system. So we used to put more high what do you call it, the traffic network cards in the system. Otherwise, the memory we used to tell that if you look at a container for each one core, we expect at least like a 2 core, 2 GB CPU, 2 GB RAM, so that we can able to get minimum container to run, pick it up, and start working on the load generator section.
Okay, sounds good. So one more question is that if we do want this to be part of continuous testing because this is all about performance, it is possible, right? Like we can enable it. Yeah.
Absolutely, because what I told you that a web interface we have, it's more like a REST API based solution, so that you can able to deploy the application, you can able to run the workload, and you can able to monitor all this. That's the one of the what you call it in the offer test use case where we deploy the OS, we deploy the application, then we run the workload and we monitor the workload. That's the continuous automation we did actually with that.